Good morning, Ananda. Today I am here by to give a presentation on working of liquid rocket engine. So, so before getting into this topic, so now let us discuss about the timeline. In in this presentation, initial stage I supposed to give an introduction on myself, and next we will discuss about the abstract along with introduction, and then we will go and we will and let us and then we will discuss about the working principle. At last we can get a conclusion. So before getting delay, let's get into topic. Before getting into topic, I give a small introduction myself. My name is G Sainath Reddy, having a pin number of 219-558-2109. My topic is about working principle of liquid rocket engines. So before getting delay, let's get into topic. Now let us discuss about the abstract. In this presentation, we are going to discuss the working principle of liquid propellant along with some fundamentals to get rid or to understand easily about the working principle of the liquid propellant. Now let us discuss about the now let us discuss about the introduction. Please hang on a minute, I will adjust my camera. Okay, let's get into topic. Introduction. A liquid propellant rocket or liquid rocket utilizes a rocket engine that use liquid propellants. Liquids are desirable because they have a reasonable high density and high specific impulse. This allows the volume of the propellant tank to be relatively low, and it is possible to use lightweight centrifugal turbopumps to pump the rocket propellant from the tanks into the combustion chamber, which means that the propellants can be kept under low pressures. This permits the use of low mass propellant tanks that do not need to transit the high pressures needed to store significant amount of gases, resulting in a low mass ratio of the rocket. Next, an inert gas stored in the tank at high pressure is sometimes used instead of pumps in simpler small engines to force the propellant into the combustion chamber. These engines may have a high mass ratio but are usually more reliable and are therefore used widely in satellites for orbit maintenance. Liquid rockets can be monopropellant rockets using a single type of propellant or bipropellant rockets using two types of propellants. Tripropellant rockets using three types of propellants are rare. Okay. So in this we can able to understand a monopolar rocket means a rocket which can use a single propellant, and next bipropellant types of rockets is basically known as in which they supposed to use two different types of propellants, and there is other type, and that is tripropellant. But in most cases we can't supposed to use this tripropellant because tripropellant are supposed to use three different types of propellant, so in which it causes a lot of mass. Now next alternatively, instead of pumps, a heavy tank of high pressure inert gas such as helium can be used and the pump foregone, but the delta V, the stage can achieve it often more lower due to the extra mass of tankage, reducing performance. But for high altitude or vacuum use, the tankage mass can be acceptable. The major component of a rocket engines are therefore the combustion chamber. And next, in this we can able to understand the basic information about the monopoly or about the rocket engines. Now let us discuss about the simplified diagram of liquid propellant rocket. So this is a basic figure of a liquid propellant rocket, in which if we clearly observe the figure we can able to identify 6 different components in detail. So now let us discuss about the each and single component of liquid propellant rocket. So by understanding the components we can able to understand the working principle more accurately and in very easy way. So the number one component is known as liquid rocket fuel, in which it is a position at which the rocket fuel is supposed to store there. And next, number 2 is oxidizer. As you know that oxygen is a main component when it comes to burning. So therefore rockets are supposed to be cross the earth orbit. So after crossing the earth orbit, we can't supposed to have sufficient we can't supposed to have the oxygen. So in order to burn or in order to get the thrust, we supposed to need the oxidizer. So for the sake of the oxygen, we will carry additional oxidizer. Next, number 3 is a pumps carrying the fuel and oxidizer. And next, by from seeing the figure, we can able to understand the label 3 component is basically known as a pump, which is used to carry the fuel and oxidizer. And the fourth component is known as the combustion chamber. In this, it is a place in which it is capable of burning. So by this we can able to understand the fourth component is a combustion chamber, in which the whole process of combustion will carried out. And so from the figure we can understand the components from 1 and 2 will travel with the aid of 3, that is known as the pumps, which carries certain amount of the fuel rocket and oxidizer and combine them together and carries to the combustion chamber, where in this combustion chamber the combustion process will be carried with the aid of external heat. So in this process the amount of liquid and oxidizer comes across and combines in a way, and when the sufficient amount of heat is added to or subjected to that, as a result we can able to get the thrust from it. And the fifth component is the gas put off by the reaction process to the throat, which aligns of all the gases produced in the right direction. And next, the sixth stage is the exhaust, in which the sixth stage is the main component, because we can able to get the so without the aid of 6 component, we can't able to produce the amount of thrust for this. So in order to produce the thrust, we are able to burn. But initially we're supposed to burn the amount of fuel and the amount of oxygen by combining together and by supplying the heat. And next, after the process of burning, and then the amount of thrust is produced by the nozzle, in which it is capable of exert it. So when the nozzle is exactly supposed to exhaust, then the amount of thrust we can able to get, because according to the Newton third law of motion, for every reaction there will be equal and opposite reaction. So whenever we can able to promote, we can able to exhaust the combustion products in a specific way, so we can able to get the amount of specific thrust by using with respect to the thrust. So by this figure we can able to understand the working principle of a liquid propellant engine. So in this presentation, the main aim is to get the understand the working principle of a solid propellant. So by the end of this presentation, we can able to understand the working principle of the rocket engine. So in this presentation, there are still many more slides in which it describes about the working principle. So let us discuss it. Now let us come into the principle of operation. So in the previous case we had discussed the working principle of the liquid rocket propellant. This is the theory information of the liquid propellant engine, in which we had discussed the previous way. Next, now let us discuss about the main use of liquid propellant, because the liquid propellant is very large in proportion. Therefore, when operated with atmospheric pressurization, it comes very thin walled projectiles, and the liquid propellants are subject to flows, which can frequently lose the control of vehicles. That's it. Next, this all we are discuss about it. Now, okay, completed. So by the end of this presentation, we come across the working principle of the rocketing, working principle of liquid propellant engines. Okay, thank you.